Hello everyone, my name is Dennis with DonkeySec here, and in today's video we're going to be going over reverse engineering. So the Blue Team Labs online, they have a lab called Nonyx, Nonyx, a very interesting name. Purify Black Energy 2 from Shadowbrook's digital infrastructure by reverse engineering the malware's code. So I gotta dismantle its hooks, identify payload, stop the C2 mechanisms, restore peace to the town's network before the haunted festival reaches its darkest hour. So looks like the tools that we'll be using is Volatility and then Malfind. So after loading into the lab, we have the readme.txt. So this is our Windows profile, so we have to use this one. It's best to place the output of the Volatility command to a text file for better readability, right? First thing I'm gonna do is copy this, open a terminal here. So we're gonna do this command, python volatility slash vol.py. This is basically how we run volatility. Black energy minus VNEM and the minus F, that is like the memory dump file that we want to analyze. And then profile win.xps, whatever, is the operating system we want to analyze as well. And then Malfind, especially in the beginning of the video when I said we're going to be using Malfind, this is how we find injected malicious code. So the main thing we want to be looking for is these right here, and they're all containing zeros. But if we scroll all the way to the bottom, we see 4D, 5A. The main thing that I see from this one particularly is the 4D and 5A, which is the MZ, which is a Windows executable file, which tells us a Windows executable file that has page execute read/write privileges is injected into a process called svchost.exe. But this process most likely contains the injected code as per question 1, so we'll be doing the name, PID, and address. Numbers right here. Right, now we got the first question correct. What dump file is the Malfind output directory corresponds to the memory address identified for the code injection? So first things first, we're going to copy the code that we just, or not the code, excuse me, the command line input that we just put right here. Then I'm just going to create a new terminal right here. This is the same input that we used for the first question. However, we just did dump directory into the outputs ls directory folder. So now we just got to navigate to the outputs folder, all of the DMP files onto the directory outputs. In order to get to outputs though, I had to troubleshoot this a little bit. You have to do mkdir outputs, and then it'll list as a directory, and then you can do the outputs right there, and then see the outputs, and then you can do ls, and then you see all the DMP files. And for question 2, what is the dump file that corresponds to this? We only have to look at the PID of this, or the address, excuse me, of that, and then we do see this process right here. Yep, answer is correct, so we just have to copy and paste that, put it on there. Now question 3, which full file name path is referenced in the strings output of the memory section identified by Malfind as containing a portable executable? So what I did here is mk directory strings, and then the strings, and then the answer for question 2, and then we get a bunch of strings right here, and we're just looking for a full file name path. And just by looking at all of the potential answers, the only file path that does show up here is this, the C drive, the Windows System 32 drivers, then str.sys. That is the correct answer. How many functions were hooked, and by which model after running the SSDT plugin and filtering out legitimate SSDT entries using egrep-v, blah 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 blah. I have to do some research because I have no idea what a SSDT is or what a hook is. So a SSDT, a system service descriptor table, which is Volatility's natural plugin. And the reason why hooks are mentioned in this question is because hooks is a common malware technique for kernel level hooking. So we just have to look for the non-standard or malicious module hooks. So I'm just going to copy this command again. Then I'm going to replace all of this with SSDT and then this sign right here. And then I'm just going to copy and paste what the question just said. I'm going to paste it on here, see if this works. Oh, it's because I forgot to copy egrep right here. So we filtered out all of the legitimate SSD hooks, and all of these hooks that are unknown are owned by one address, which is 0004A2A. And the reason why it's malicious is because all of these NT-delete value key, NT-open thread, NT-open process should be owned by actual Windows processes such as Win32K or the kernel.exe. So there's 14 functions that were hooked, and it's owned by this address right here. So using the modules or the mod scan plugin to identify the hooking driver from the SSD output, what is the base address for the module found in Q4? So yeah, we're just gonna copy the input again. So we're gonna erase all this, put modules, and we'll put the greater than sign right here. And then outputs / modules dot text. Then now we're gonna go cd outputs, and then we do cat modules.text, and then this sign, and then more. These are the modules from the hooking driver from the SSD-T output. And yeah, but yeah, we do see some interesting file directories, such as why is the bootvid in a system32, because a legit bootvid.dll should not be appearing in these scans, because bootvid.dll is not a kernel made driver, so it should be automatically done, like the bootvid function should be automatically done by a sys driver, and there's no extension. It's just bootvid . So looking at the question 5, or excuse me, question 4, the 482, that we can have the base value of it is right here, so we just copy it, and this should be the answer right here. All right, what is the hash for the malicious driver from the virtual memory image? So same thing as last time, we're just gonna copy this, paste it onto our clipboard. We're gonna remove all of this mod dump -b, and then what we just pasted onto this, we're gonna paste it onto here as well. Then -dump -dir equals outputs, and I ran out of room, so let's just paste it onto here really quick. Yeah, so get out of the outputs directory and then paste this in. It's just basically like a mod dump of the previous base address that we found in question 4. Now we're identifying the hooking driver from the SSD-T output, which is this address right here. Then we're just pasting that address onto this mod dump and then putting it into the outputs directory. So we have a result of driver.ffd, and then let's definitely copy this. Just do cd outputs, then ls, and then we can just do SHA-256, paste this. Yeah, do SHA-256 sum, and then we do the driver file that we just found, and then this should be the sum for question 6. Nice, we have finished the lab. But yes, ladies and gentlemen, we have finished the lab. I learned a lot about reverse engineering malware code. I think it was pretty awesome. Definitely had some help in the video, but it definitely learned a lot. And like always, if you guys did enjoy this video, I will see you when I see you in my next video. Peace out.